Good evening all, this is Indra from Pantech E-Learning. I warmly welcome you all to my session. Am I audible? Anant Shrikar, good evening. Balaji, good evening. Surya, Marimuthu, good evening. Joyce, good evening. Godwin, Anthony, good evening. Yeah. Batmavati, good evening. So today is our fourth day of IoT Masterclass, right? Yeah. Narsimulu, yeah. Kaja Farid, good evening. Anthony Joseph, yeah. Thank you all for your response. Harit Chandan, good evening. Okay, actually yesterday we supposed to cover 3 topics, right? But due to the delay, we only okay. So in yesterday's class, some of you are asking to explain the program which we have used in yesterday's class. So now let me explain the 2 codes which we have used in yesterday's class. Later then we can go for the remaining topics, okay? Shall we start? Shall I? Yeah. Good evening all. Yeah, Refuse. Good afternoon. Okay. So see, this is our ADC potentiometer program. So let me explain this. So first line, constant integer analog in pin means analog input pin. I have declared here A0. So this line, this particular line declares a constant integer named analog in pin, and we assigned it the value with A0. So A0 is nothing but it represents the analog input pin on the ESP8266 board, and it corresponds to that particular pin where you connect that analog sensor. So we have mentioned our pin number in the global declaration. Govindraj, I will tell you all the hardware in the tomorrow's class, okay? If I am telling now, maybe I am going to miss some components. So I will list it out and I will tell you all the components which we are going to use in this entire masterclass in tomorrow's class, okay? Okay. So this one, integer pot value which is equal to 0. So this line declares an integer variable name pot value. This is equal potentiometer value, and it initializes its value 0. So this variable will be used to store the sensor reading. And coming to void setup, inside they have given like serial dot begin with baud rate 9600. So this function is the ESP8266 setup function. It runs once when the board is powered on or reset. So in this case, it initializes serial communication with a baud rate of 9600 bits per second using what? Serial dot begin function. So this is commonly used for communication between the Arduino board and a connected computer for debugging purpose. And coming to the loop function, inside loop, the first line is for which run continuously because we gave it inside the loop function, right? So this run continuously. In this line, first what it will do in the sense, it reads the analog value from where? From this particular pin specified by analog in pin using this analog read function, and it stores the result in the pot value variable. And these line print the text first, pot value, to the serial monitor, followed by the value of the original value, pot value. So this allows you to monitor the readings from the analog sensor. And coming to delay, this line adds a delay of 1000 milliseconds, which means 1 second between each iteration of the loop. So what it will do, this slows down the loop, prevent the serial monitor from being flooded with data too quickly. That's why we go for delays. Okay. So this is the first program, which is ADC potentiometer. Is it clear, everyone? Shall we go for the next program? Today we have to complete 3 topics. Okay, so let me move to the next one, which is LM35 sensor interface with ESP8266. So see this. Okay. So the first line. Here, float voltage reference, which is equal to 0.3. So this line declares a floating point variable name voltage reference, and it assigned to the value of 3.3. Why 3.3? This variable represents the referent voltage. Note this, referent voltage for the ADC on the ESP8266 board. We are using ESP8266 board. The reference voltage on the board is 3.3 volt. That's why I gave 3.3 here. So coming to the next line, float resolution, which is equal to some calculation. So this line declares another floating point variable name resolution, and calculate value by dividing the reference voltage by 1023. So the value 1023 is the maximum digital value that can be obtained from a 10-bit ADC on our ESP8266 board. Then we can go for void setup. Inside we gave serial.begin. This for just communication purpose. And if you go for void loop, the first line. So in this line, what we have to do, reads the analog value from pin A0 using the analog read function and stores the result in the temperature variable. So now add 2 more calculations. So the first calculation, this line multiplies the temperature value by the resolution value for what? To convert ADC reading to a voltage value. Now another calculation. This is for converting temperature value in degree Celsius. So this line multiplies the voltage value by 100 to convert it to a temperature value in degree Celsius. And then what we need to do? We need to print that output in our serial monitor. For that, we gave a serial.print temperature followed by degree Celsius and then delay. So this is all about the 2 program explanation. So shall we move to the today's topic? Shall we? For that, let me open new sketch. I'm going to cancel this. Okay. So now we are going to see ESP8266 NodeMCU pulse width modulation with, sorry, I gave Arduino IDE, not, yeah, correct. Arduino IDE, but we are going to use ESP8266 NodeMCU. Okay. So we are going to adjust the brightness of the pulse width. Sorry. Going to adjust the brightness of the LED using pulse width modulation. Okay. So now let's see how to generate pulse width modulation signals with ESP8266 NodeMCU using Arduino IDE. As an example, we will dim the LED brightness by changing the duty cycle over time. Okay, so see this. The ESP8266 GPIO scan set either to output 0 volt or 3.3 volt. We can vary between 0 to 3.3 volt. So, but what? They can't output any voltages in between. I am talking in normal time. So, however, you can output fake mid-level voltages using what? This pulse width modulation. If you are going to write a program like a blink LED, it will on, it will off, it will on, it will off. We can't adjust the brightness and we can't use any voltage in between that level, right? It only gave the highest voltage like 3.3 volt. So using this pulse width modulation, we can vary. We can vary the voltage. Okay. So, if you alternate an LED's voltage between high and low very fast, your eyes can't keep up with the speed of which the LED switches on and off, right? You will simply see some gradations in brightness. So that's basically how pulse width modulation works. By producing an output that changes between high and low at a very high frequency. Godwin, why temperature cross 100 use? Because we are going to convert that temperature value into degree Celsius, that way. First calculation is for converting the ADC value to the voltage. Then we are converting that voltage to degree Celsius. For that I have used temperature into 100, okay? Okay, see now there are two important parameters associated with pulse width modulation signal. What are they? Drop the answer in the chat box. What are the two important parameters associated with pulse width modulation signal? If you know the answers in the sense, you can drop the chat box, answer in the chat box. Those who have knowledge on pulse width modulation, please drop the answers. Those who don't know, it's okay. Let's see. What are the two important parameters associated with pulse width modulation signal? Duty cycle, yeah, correct. Another one is duty cycle, another one is T on and T off, no. Time period on time, okay, but yeah, frequency time, not time, frequency, okay. These are the two important parameters associated with pulse width modulation signal. One is duty cycle and another one is frequency. Okay. Thank you for your response. Yeah, okay. So now let's see. First one is duty cycle. So this is the calculation for find out the duty cycle. Those who are say like turn on time, turn off time, this is the calculation for duty cycle, okay. So see, as we know, a pulse width modulation signal stays on for a given time and stays off for a certain time. So the percent time, here you will see like 0%, 100%, 50, 20, 80. So the percentage of time for which the signal remains on is known as the duty cycle. If the signal is always on, then the signal must have 100% duty cycle. For that like 0%, which means it is in off state. So the formula to calculate the duty cycle is turn on time divided by turn on time plus turn off time. So the average value of the voltage depends on the duty cycle. As a result, the average value can be varied by controlling the width of the on of a pulse. So this is what duty cycle. The next one is frequency. So here you can see this is the on time. When it's in high, it's on time. When it's in low, this is off time. What is called period? On time plus off time is called 1 period. Okay. So the frequency of pulse width modulation determines how fast a pulse width modulation completes a period. How fast PWM completes a period. So this is the formula. The frequency of pulse width modulation can be calculated by frequency, which is equal to 1 by time period, which means on time plus off time. On time plus off time, which is equal to 1 period. This is how you will calculate your frequency of pulse width modulation. So the next one is, here see this function, analog write function. We have already used analog read because we read some data from sensors or analog pins. For that purpose, we go for analog read function. But here, we are not going to get any data from this, right? So we are going to use analog write function to generate a pulse width modulation signal on the ESP8266 pins with Arduino IDE. We have to use this function analog write. Inside the parenthesis we have to pass some parameters. What it is? First one is pin, which pin we are using, and value. So what is the range? 0 to 255. This is our range. So we have to mention pin number here and we have to mention the value here. Prasad Patil, wait until the class ends, then you will get your attendance link. Okay. So we can use pin from 0 to 16. I already explained it in the pin section, right? So coming to value, the value is an integer between 0 to 255. It should be in the range from 0 to PWM range, which is 255 by default. When the value is 0, pulse width modulation is disabled on that pin. When the value of 255 corresponds to what? 100% of duty cycle. You can also change the pulse width modulation range by calling this function analog write range of new range, and by default ESP8266 pulse width modulation frequency is 1 kHz. You can change pulse width modulation frequency with this function. And the another one is analog write frequency. Inside the parenthesis, the parameter called new frequency. So valid values are from 100 Hz to 40,000 Hz. Okay. So now we are going to write a program. Okay. So before that, let me add a global variable. What I am going to do is that I am going to give constant integer. We just only need one component, which is LED, because we are going to adjust the brightness. Okay. So see this constant integer. I am going to give a name like LED pin. Okay, let me give like this. It is equal to, I am going to take D1. Okay. So inside void setup, I don't have to give serial dot begin and baud rate something, because we are don't want to communicate with anything, right? So we can directly jump to the void loop. So see this. Here, first we have to create a for loop. For what? To vary the duty cycle between 0 to 255. First I am going to increase the LED brightness. I am going to write a for loop for increase the LED brightness. So I am going to use for. Inside I am going to give a variable name like integer duty cycle, which is equal to 0 to 255. So 0 semicolon, again duty cycle, which is lesser than 255. This is our maximum value, and then duty cycle I am going to give an increment. So this is our first for loop for increase the LED brightness. So inside what we have to do? We have to set the brightness of the LED. For that we have to use analog write function. So inside what we have to pass our pin number and the value. So pin number is what? LED pin. Copy this. I am going to paste it here. Then value. Value is what? We have already gave in the for loop. 0 to 255. So what we have to do is that we have to give the duty cycle variable name here. It will take the value from this loop. So this function use pulse width modulation to vary the brightness of the LED by rapidly turning it on and off at a different duty cycles. So now I am going to give a delay, little delay. Just 10 milliseconds. Not 1, just 10 milliseconds. Now again for loop. This is for decreasing the brightness. So same for loop inside integer duty cycle, which is equal to, here we are going to decrease. So what we have to do? We have to give 255. Here we gave 0 and here we gave 255. So here we are going to increase. Let me give a increase. Here we are going to give for decrease. So second one is duty cycle, which is greater than 0. Now duty cycle decrement. Make you like decrease. Okay. So inside what we have to do? Using analog write. First we have to mention the pin. LED pin, comma, duty cycle. Then delay of 10 milliseconds. That's it. So now, just a minute. Now we need to give a hardware connection. Duty cycle, LED pin. Are you able to hear the video? We just need one LED, one resistor and two jumper wires. So first, I am going to connect the negative leg to the ground and the positive leg, we have taken the pin number D1. So I am going to connect this with D1, which is here. That's it. You can also give D1 directly to here for just if you want to give the particular variable name and you have to make it clear in the sense, you can go for this global declaration like LED pin, everything and all. If you don't want to give in the sense, you can directly go for the pin number here. You can use this method or you can use it in your own way. Both are correct. I need to mention that this particular D1 pin is for LED pin. Okay, just we are going to use only one LED. In later program, in later topics, we are going to maybe we can use 3 LEDs, 4 LEDs, and two or more sensors. So we have to mention each name. Then only we can get to know which pin corresponds to which LED corresponds to which pin for. Okay. So now let me connect the board to my. Okay. So now we need to select our board first, 12 okay, and then tools, port, component. Now let's upload the code into our ESP8266 microcontroller. So it's compiling. Some port failure. Wait for a few seconds. After showing the output, I will again explain the hardware connection. Okay. It's uploading. Here you can see it will gradually increase and it will gradually decrease. Is it visible? Are you able to see the output clearly? Wait, I will show you. Visible? It's gradually increasing, it's gradually decreasing. Zero to 3.3 volt. This is our output. Is it clear, everyone? No? Okay. So thank you for your response. See, I have taken two jumper wires, one LED and one resistor to resist the current. Okay. So, in LED, one is the positive leg and another one is the negative leg. The short leg is negative, the long leg is positive. I have placed here like this. You need to connect the negative leg with ground. So, to the positive side, we need to give this resistor. I am going to place it like this. So, at the end of the positive leg, I mean one side of the resistor, you have to connect this with D1 pin. Where is? Here it is. That's it. Is it clear? If you are new to electronics in the sense, please go to Google and check the inbuilt process of the breadboard. Go and search like how breadboards connections are. Then only you able to get to know how to place that pins correctly. So here you will get the pins like in vertical form, and here you will get the pins like in horizontal form. So please go and check that one before connecting all the hardware things. Okay. Okay, let's try that also. If I change the duty cycle in a sense, so see, let me give 1 second. What will happen? So see this. Positive end is connected to the resistor. Now see, introducing okay. Let me explain this from the starting, okay? So see, let me introduce this topic first. Deep sleep mode. If you have made a project with an ESP8266 board that is like battery powered, or if you just connect your ESP8266 NodeMCU board to your power bank and for a while, you realize that battery doesn't last long, especially if you are using Wi-Fi. Are you able to hear me? Am I audible? If I am audible in the sense, please drop S in the chat box. Okay. Guys, am I audible? There is some internet issue here, that's why it doesn't stream properly. Am I audible now? Yeah. Thank you for a response, Javik Joyce. Okay. So see. Okay. So if you put ESP8266 in deep sleep mode, what it will do? It reduces power consumption and your batteries will last longer. So having the ESP8266 in deep sleep mode means cutting with the activities that consume more power while operating like Wi-Fi. So it reduces power consumption and your batteries will last longer. So using ESP8266 in deep sleep mode that consume more power while operating like Wi-Fi but leave just enough activity to wake up the processor when something interesting happens. So let's see what are the types of sleep. You can see there is 3 different types of sleep mode. One is modern sleep, light sleep and deep sleep. So coming to modern sleep, first let's see this column, modern sleep. In this mode, Wi-Fi modem is turned off while the CPU and the system clock and the RTC remain on. So this mode allows the microcontroller to wake up quickly and connect to the Wi-Fi network when needed. So coming to light sleep, in this mode, both the Wi-Fi modem and system clock are turned off, while the CPU and the other components such as RTC remain on. So this mode consumes less power than modern sleep, but takes a bit longer to wake up. And if you are taking deep sleep, so in this mode, almost like all system components including CPU and system clock are turned off except what? RTC. So this mode consumes the least power and has the longest wake up time. Those who are asking for attendance, sorry guys, both of this class, that's why you are keep asking the attendance. Can't you wait for a few minutes? If the session is boring, okay. See, I will provide you the attendance link. Wait until then. So see, the table also shows the power consumption of the Wi-Fi module different states. So when the Wi-Fi is turned off, it consumes no power. When it is turned on, it consumes a significant amount of power. RTC means real-time clock. So it depends on the level of activity. So the table provides an estimation of average current consumption in milliamperes for like different scenarios, assuming the microcontroller is operating at 3.3 volt power supply. So lower subtract current in deep sleep mode signifies minimal power consumption, which makes this mode suitable for like battery power devices. So where power conservation is a crucial factor. So note that the power consumption on the tables refers to only ESP8266 as a standalone chip. I am talking about chip. When we are using a development board, they have passive components that use more current. In this session, we are using development board, but this tabular column is only about the bare chip. If you are taking development board, that uses more current. Okay, so next, see, they all have different purpose and they should be used in different applications. So, but here we will cover deep sleep mode. Everything is always off except the RTC, which means real time clock, which is how the ESP8266 keeps track of time. So this is the most power efficient option. The ESP chip only draws approximately like 20 ampere something. However, if you use a full feature development board with a built-in programmer, LEDs and so on, you won't be able to achieve such a low power state. So what are the wake-up sources? After putting ESP8266 in deep sleep mode, how can we wake it up? There are two different ways to wake it up. One is timer wake up and another one is external wake up. So first one is timer wake up. So to use timer wake up with ESP8266, we need to connect the reset pin to the GPIO 16th pin, which is labeled as D0. I have already told you that D0 or GPIO 16th pin is for deep sleep in a ESP8266 NodeMCU board. But we have to connect the reset pin to GPIO 16th pin only after uploading the code. Note that after uploading the code into our ESP8266 board, you have to connect the reset pin to GPIO 16th pin. The reset pin of the ESP8266 is always high. Always high while the ESP8266 is running. However, when the reset pin receives a low signal, it restarts the microcontroller. If you set a deep sleep timer with the ESP8266, like once the timer ends, GPIO 16 sends a low signal. A particular pin, when connected to the reset pin, can wake up the ESP8266 after a set period of time which you have set in your program. Is it clear? This is what deep sleep will do. So now we can go for the programming part. Let us write a code for that and let's see what will be the output. So see, directly we can go for void setup. There is no need for declare anything in global. So inside I am going to give like serial.begin. We need to pass the baud rate which is 9600. Now I am going to use another function called serial dot set time out. Inside I am going to pass 2000. So see, this line sets the timeout for the serial communication to 2000 millisecond. This is nothing but second, millisecond, which means 2 seconds. So this means if no data is received over the serial port for 2 seconds, the serial communication will be stopped. So now I am going to create a loop, while loop. Inside I am going to give like exclamatory. We don't have to give anything, just a while loop. So what are the purpose of this while loop? So this line waits in a loop until a serial connection is established. So this is useful if you want to wait until you see the output of the board over the serial monitor before proceeding. Okay. So now let's print the message. What I am going to print is that after the while loop, I am going to print a message like serial println. Instead I am going to give a message like I am awake. But I am going into deep sleep mode for just 30 seconds. This is what I am going to print. We will get the output in the serial monitor. What output? This will print. For every 30 seconds, it will print like I am awake, but I am going into deep sleep mode for 30 seconds. So now, let's put the board into deep sleep mode. We have give the message like I am awake and I am going to in deep sleep mode for 30 seconds. So how we put that board into deep sleep mode for 30 seconds? There is a function called ESP deep sleep. So inside you need to pass, wait, I am going to give 30E6. What is this? 30E6. What it means? So the parameter given to the function is the number of microsecond the board should sleep for. This is nothing but 30 seconds. 30E6 is scientific notation for 30 lakh microsecond. We need to pass the seconds in microseconds. 30 seconds, which is equal to 30 lakh microsecond. 30E6 is nothing but the scientific notation for 30 lakhs microsecond, which is equal to 30 seconds. Is it clear? That's a function called ESP.deep sleep. Inside we need to pass this parameter. So now while loop, but there is nothing we can do with while loop. So let leave this blank. In this case, we don't need to do anything in the loop when the board is sleeping, right? So we can leave this. So this is our program. So now let me, okay. So see, first we need to upload the code. Okay. So let me upload this. After uploading only, we need to give the connection. Just one jumper wire. Yeah, it's uploading. Yeah, let me open the serial monitor now. Now we have to connect this D0 pin with reset pin. Here is our reset pin. See, after giving the connection, you can get the output here. I am awake. I am going into deep sleep mode for 30 seconds. Note, you will get the same message again after 30 seconds. Let's see. It will print this message for every 30 seconds. See, after 30 seconds, we got the message like I am awake, but I am going into deep sleep mode. It will print continuously until I power off my board. This is our output. Is it clear, guys? Yeah. They will provide you the attendance link in few minutes. Please wait for few minutes. They will provide you now. It's already 7:50, right? Okay. They will provide you. Okay. We just complete the yesterday's remaining portion, which is pulse width modulation and deep sleep. Today we suppose street light. smart street light. That's what today's topic. But I think it's already 8. We can't cover that topic within 10 or 15 minutes. It's take time. So let's continue the today's topic in tomorrow's session. Let's try to cover today's topic and tomorrow's topic in tomorrow's class. I'll try to complete 2 topics at the same time, okay? How 30E3 comes? It's supposed to be like 30E6, right? Scientific notation of 30 lakh microseconds, I think. Or if I wrong. Both are same, Jaivik. ESP8266 and ESP32. You can do the same thing in ESP32 also. Okay. So this is our output. Is it clear, everyone? So today we don't have time for the last topic. Today we supposed to cover like smart street light, but I think it's already 8. So in tomorrow's class we cover that topic and tomorrow's topic too. Okay. So is it clear, everyone? Okay, attendance link have provided. You can go for that link. Thank you for your response. No. 30 seconds it will go for a deep sleep mode. After 30 seconds it will be awake. And then it will go for a deep sleep mode for 30 seconds. While loop, yeah. See, for it will wait. This loop will wait until a serial connection is established. Like this is useful if you want to wait until you see the output of the board over the serial monitor before proceeding. Okay, that's why. Yeah, this is the code. You can go for it. Just a few lines of code. Serial begin, and you have to use that serial dot set timeout function. Inside you need to pass the microseconds for waiting while loop, and I'm going to print a message like I'm awake everything, and you have to put that 30 seconds using the ESP Deep Sleep mode. This is for 30 seconds scientific notation. There is no need for giving anything in the while loop. Okay, guys. Yeah, I need to explain one more thing. I forgot to tell that. So see, the another thing which is external wake up. You can also wake up the ESP8266 with an external wake up, like a press of a button. You can additionally add a button or a read switch. You just need to put ESP8266 in deep sleep mode for an indefinite period of time, and then set the reset So to wake it up, just give it a try. Try to write the code for that using one external source, like it can be a button or it can be a reed switch. Using that also we can wake it up with the external source. So in total, what I want to say is that ADC, pulse width modulation, and deep sleep are important features of ESP8266 microcontroller that allow it to interface with analog signals, control power which is delivered to devices, and conserve power when not in use. So understanding these features is essential for designing efficient and effective ESP8266 based project. Means what? Whatever you are using that source to wake it up, it is what? External. We just use the internal thing. One is reset button and another one is D0. External means you can use a button or a reed switch. Using that you can wake up your ESP8266 mode in deep sleep. That's what external source called. You can take any pin for that button. Take one button and make the connection. You can take any not any pin. D0. Here we connect reset with D0, right? For that you have to connect that button to that GPIO 16th pin, which means D0. What? Internal wake up, timer wake up, or internal wake up. External wake up means you can use some external source. Okay guys, thank you for today, and let's see the remaining topic in tomorrow's class. I'll try to cover today's topic and tomorrow's topic in the same day in tomorrow's class. Okay.